What do I have?
-5.
Oh, -10? Like this? Oh yes, thank you. Thank you, yeah, got it. Okay, let's run this. Okay, so in fact, this machine actually does have, give me a big stack. And in fact, it's reasonable, right? Because I only have an array of 1 million integers, and each integer is 4 bytes. So I'm only asking for 4 megabytes. 4 megabytes is peanuts for most compilers, right? Most runtime systems, they'll just give it you 4 megabytes is on a stack. What I need is a much bigger stack. Let's make it 400 megabytes, right? 400 megabytes, I'm very almost certain that I won't get a stack that is 400, half a gigabyte in size. So let's run this and see what happens. Oh, it still works. Why does it work? Let me try 1 billion, right? Oops. 1 billion. Okay, all right. And I do have an error, a warning.
So you just printing
Hmm?
when you are C out, at the C out you're just printing a million.
I don't see the error. What is it? Do I see? What is it?
Everything falls on.
Further down?
For the C out.
Yeah.
Stack of ends, and then you're just printing a million instead of.
Oh, I'm sorry. Thank you so much, guys. It's staring me in the face, and I didn't see it. Okay. Well, I'm not sure why this works, honestly. Because I'm pretty sure that I don't get a stack of 1 billion items. Maybe. Let me do this, okay? Give me 1 second, because this is not. Let me see. I'm going to put a loop here for int I equals 0, I less than, let's say 100,000. I'm going to put a value in there. Stack of ints.
Random access memory.
Okay, oops.
Wrong.
Alright, so I push it in. Now all I need to do is just print it out again. I will print it out. But I'm not sure how is it possible that I get 1 billion item stack? Oh.
Wouldn't the compiler optimize that and say that you're only actually accessing?
Yeah, I'm pretty sure.
I don't think so. I don't think a compiler, even today, I don't think a compiler actually runs the code to find out. It can only look at the code. It can't run the code and optimize it.
It can look at your code and
Oh, but yeah, but in order to know,
Yeah.
I see what you're saying. You're saying that the compiler can look at it and say, well, I'm only accessing this many elements, so why don't I not have space for the rest of the elements? I think that optimization is currently beyond the ability of modern compilers because it actually needs to understand the code a bit to do that. Compilers, despite their intelligence in optimizing a great deal of things, I think they're not intelligent enough to do that yet. But let's see. But what I'm guessing happens is that the stack allocation failed. It actually failed, but the error is raised only when you try and access the memory location that doesn't belong to you. So it failed, and I don't have all these memory locations, but I'm not writing to them, so it's just letting me do it, right? So I'm going to write to them now, to all those locations, in the hope that one of them will throw an error. So I'm going to print that, and I'm going to see how this do. By the way, is it okay that I just code these random things here? And yeah, is it okay? Okay, cool. You just have to let me know if you don't want me to do this, and if you'd rather be coding something else, that's fine with me. Let's do this. Okay. Stack of ints set but not used. Okay, we're running.
You're missing a brace on your top 4 statement.
Oh, thank you, John. Okay, well, apparently it is running, because it is taking a long time to, where's my, it only has to do 100,000. It has to do an iteration of 100,000. Oh, it actually finished, and it didn't produce any output. Let me say, so that's 10,000. Okay, so it is dying, but this program, if I did the same thing in Xcode, we'll see, right? This, all said and done, CPP.sh is a web app. It's running on a remote host. They're capturing the error and sending it back to us. Suppose my program died in an unexpected way. But if my program died in an expected way, saying, oh, I died, this is the error, I'm pretty sure their remote app will pick up the error and send it through to the web browser page, so I can see it. Like if I had a blatant error, right? If I had something like this here, if I compiled it and it didn't, so yeah, you get the error back. But I think with this, with a Stack Overflow, not Stack Overflow, right? There's a stack error. It's an unusual death, and because the program died unusually, I think they don't know how to surface that error back to me. That's my guess, because let's take this and put it in Xcode. We'll see exactly what's going on. Okay, so let's go to my Xcode and new. Let me open a new project for now. A new project. Okay, and I'll call it experiment arrays. Okay. I'm going to delete this later, so I'll put it on my desktop, so I need to remember to delete it. All right, so here I am, and I'm going to go to my main, and let's paste. Oops, not here. Okay, so I pasted this. Let's compile this. I'm pretty sure Xcode will tell me, because they can give me 1 gig of stack space. And okay, so it succeeded, because the compiler can't tell if it's wrong or right. Because if what John said, if the compiler was intelligent enough, it could have told me right now, hey, you got a too big. Oh, it already told me something here. Bad access. Did I run it?
Yeah.
I did run it. I did run it, huh?
Yeah, you ran.
Okay, that's fine. Okay, there you go. Bad access. What that means is that I'm accessing memory that doesn't belong to me. That's what it is, right? So I'm gonna have the same thing in Unix, and it'll probably give me a segmentation violation or something like that, right? So let's go to a terminal. Let's go. Can you all see the screen?
Yeah.
Okay. Cat experiment.cpp. Right? Okay, I'll put it there. Now I can just g++-o experiment.cpp. All right. So let me create this file. Okay, so I've compiled this code on Unix or a Linux system. Let's run it and see what happens. There you go, segmentation fault, right? Segmentation fault is the Unix way of telling you a bad access, right? It says, oh, you're trying to access memory which is outside the segment that was given to you. So that's a segmentation error. Now, if the same file had a smaller, oops. Oh, by the way, I accidentally edited the binary file, expd. This is it, right? These are binary numbers. This is the actual machine code for this chipset on this laptop. Right. So .cpp. And if I didn't have that many integers in the stack, I only had 1 million. I bet this will work, okay? In fact, you see this code is really horrible because I'm using these numbers. I shouldn't be using hard-coded numbers like this, right? I mean, so I should be saying something like const int array size equals 1,000 times 1,000 times 1,000, right? And then I should be using here. So that's a more documented, better way of writing the code because you can actually see what's going on. There's only one place I need to go to change the size of the array, right? So anyway, so if I change that to 100,000, 1 million, I'm pretty sure it'll all work, okay? So if it's 1 million, in fact, we should just have used array size here. So let's say replace 1,000 times 1,000 times 1,000 with array size. And replace that. Is there only one? Oh, I changed this already too. Okay. Yeah, I don't need these. All right, and this should be Oh, we're just iterating through our stuff. Okay. And then, again, yeah, those are fine. Okay, so if I run this, I'm pretty sure that it'll actually work. There you go. See, that works because I'm using a smaller array. Does that make sense? So if I use a small array, the entire array goes on the stack, and it's able to fit, so the compiler will let it, run. If I use a big array, now the way to handle a big array is to simply say, let's go back to Xcode. Right? If I want a big array here, I would simply say include a vector, right? Hash include vector. Now vector is basically a class. It lets you create an array object, and the object is not stored in your stack, it's stored in the heap. Now, a vector can have as many elements as you want. So I can say here, and say vector array of ints of, I don't know, let's say in a const int array size equals 1 billion. Okay, that's 1 billion items. And I can have, okay, put that in a vector instead of an array. Oh, by the way, a vector is a class, it's a constructor, so I call it like this. Okay? And then let's get rid of the stack. We don't need the stack like that anymore. But in here, I'm just going to put the value that I'm after inside the vector. Oh, now what is it called? Array of ints. Okay, so and I think this should be array of ints minus I. Array size minus I. Oh, geez, I've forgotten the syntax. Okay, I'm saying it's a vector of integers. I want a vector of integers that big in size. If any of you don't understand the syntax in any of these, or something, if you're lost, just let me know. Okay, I'm happy to explain that. All I'm doing here is this is my main program, and then here is a constant number that I've defined. It's the size of the array, and then I'm declaring an array vector, which is basically an array managed by the system of that size, 1 billion. And here I have a loop. We talked about loops last class, right? Yeah, last week. Okay, so I have a loop which basically iterates through the entire array, not the entire array, the last 100,000 of the elements of the array, and put some numbers in there. So this should not work if it was on the stack, but we will see that it actually works because it's on the heap. Right? Okay, and this should also be array size minus 1. Okay, we don't need these. That's cleaner, much cleaner. Okay. Okay, that looks cleaner. Right, so now this I can build. Kill the existing run maybe. Okay, I can build this. Command B to build it. Okay, build succeeded. Now I can run it, and I bet it'll run. Even though my vector has 1 billion elements in it, it'll run because the 1 billion elements are not in my stack if the compiler is able to command R, right? So build succeeded, and I bet that it's going to output, if I'm patient. Why is it not command R? Should run it. Am I not printing anything? Why is it not printing anything? Oh, it was actually printing. It's just it was initializing. Oh yeah, I know why. I think I know why. Yeah, it is actually printing these values. So the reason it was slow, I believe, is because I asked for so much memory on the heap that, and because my computer has not been rebooted in quite a while. Right? This is a very obscure reason, right? But it's interesting, I think. Right? My computer has not been rebooted in quite a while, maybe 10 days or 15 days, I think. Right? Therefore, there's lots of processes that I started and killed and started and killed, YouTube, all those things, Chrome. So my memory is highly fragmented. Right? This is memory allocated and released, allocated here. So there's lots of holes in my memory. So when I asked the system, give me what is it? 4 billion bytes. 4 billion. That's 4 billion, 4 gigabytes of heap to use for my stack, for my array. An array, what was the most important distinguishing characteristic of an array? All the elements have to be contiguous, next to each other, right? So because my memory is so fragmented, it couldn't find 4 billion bytes of memory next to each other in one place. However, I did have 4 billion bytes of memory free because it succeeded, right? So what happened? So the delay was because the memory manager on this Mac kicked in. and said, hey, Anand wants 4 gigabytes of RAM, I actually do have 4 gigabytes, it's not just all in one place. So let me do some rearrangement internally and move all the free stuff to one place, so that now I have 4 billion contiguous bytes that I can give Anand, right? So that rearrangement happened by the memory manager. That's what took time. Christopher?
So this is just basically defragmentation.
Defragmentation.
Oh.
Exactly the same thing that happens with